Hello, in this video I'm going to do the polymorphism exercise using the Simpsons as an example, because why not? So what I'm going to do is make a form with a picture of one of the Simpsons characters on it, and when I push the button, that character will say something. So each character is going to be represented by its own class, and when we click the button, the form isn't going to care what specific character is supposed to speak. It just knows it's a character, and that's okay. So that's where the polymorphism comes in. It's the form can treat all these different Simpsons characters like they're the same thing, like they're one type of character base class. So I've resized my form there, and let me drag some buttons on there. I'll bring up the toolbox. And what I'm going to have is two buttons here, so I can cycle through my different characters. There we go. And maybe I'll throw a menu strip on here with file quit. File exit. So capital E ampersand XIT, and double click on that. And application dot exit. There we go. And I think, yeah, I guess that's it. All right. And let's go rename these buttons here. So this guy will be previous. This guy will be next. And this one will be the speak button. There we go. And let's throw a picture box on here. And the dimensions of the picture box will be 220 by 175, because that's the size of the pictures and the resources. So this will be size, I'll put in 220 by 175. There we go. That doesn't seem right somehow. 220 by, okay, well maybe we'll change it later. All right, and then let's go grab the resources. So that'll be up here. Project, properties, resources, no, not debug, resources, add existing file, and I'm going to go into the resources for that project, which I thought were there, but apparently they're not. Arg. All right, so for me they'll be in C. Users. For you they'll be wherever you unzipped them. Oh, wait. Documents. I know where I can find them. Documents. For me, I'm sorry, I have so much stuff. Teaching. C#. Simpsons. There we go. So for you, they'll just be wherever you unzipped them. Let's go grab those resources. I'm just going to hit all of these. I'm going to grab all these sound bites and images and import all of them. There we go. So we've got Flanders, Homer, and Ralph. And I'll save my project just to be safe here. And let's put Flanders in there for now, and then select size mode, auto size. There we go. So what size did that guy actually end up being? That's kind of an interesting question. He ended up being 187. No. 175 by 220. Ah, okay, so I've got it backwards in the instructions. All right, well, we got it fixed now. All right, and now we've got everything we need as far as our resources and our interface, and you can shrink this a little bit if you want, and kind of make it a little not such a screen hog. It's all right, either way, it's all good. Kind of feel like Bob Ross right now, You make your forest your way. Now let's go to the code. And what we're going to do now is implement this object hierarchy. We're going to make, this is our base class here, the character class, and it's going to have a public field called name, a public field called image. Maybe those could be properties. And it'll have a list of sound players and a random number generator. And it'll have a public function called speak, but speak will be abstract. It won't have a body. These specific subclasses, oh, that's supposed to be Homer. Ned, Homer, and Nelson, or whatever. These will be different characters that are going to implement that. So we'll have Flanders, Homer, and Ralph up here implementing our subclassing our character class. So let's go build this class right here. I'm going to make a class called character. Actually, if I just type in class, what happens? Class, tab, tab. There you go. We'll make a class called character. And let's add a public property for the name. So I'll type prop, tab, tab. We'll make that a string. We'll give the character a name. And let's give the character an image. We'll make that a property too. Property, tab, tab, image. I think we can just call it image like that. A property and have the same name as a type. What else do we have in here? The protected list of sound players and the random number generator. So if we're going to be playing sounds, we want to import system.media. Using system.media. Okay, and so we need a protected list of sounds. Protected list of sound players. We'll call it sounds. So it's protected, meaning it's not public, but the subclasses, the individual characters, can see it. And then we'll say equals new sounds. Oh, you know what? We'll do that in our constructor. We'll do that just as a demo here. And then what else do we need? We need our let's add a constructor, public character, and in there we'll say our sounds is equal to a new list of sound players. And what else? We need our random number generator. Let's make that static, so they don't all need their own random number generator. Rand equals new random. All right, there we go. And this needs to be protected. There we go. Otherwise, the subclasses won't be able to see it. If you don't give it an access modifier, it's private by default. All right. What else? What do we need? We need our abstract. Well, let's just start with a regular function here. We'll make it public void speak. So that would be like a regular function right here. And if we wanted the subclasses to be able to override it, we could make it virtual. Public virtual override speak. Okay, and then the base class implementation wouldn't do anything. Or we can just mark this abstract and not even give it a body. There we go. So we've got a, this is correct. Don't let the error message fool you. So this now we have this is the signature for a function that has no body. Subclasses are forced to provide an implementation for the speak function. So character is really just an abstract type. You can't make a character. You have to make a subtype of character. Now, why are we getting an error message here? Well, because this function is abstract, the entire class that it goes in has to be abstract. Because if you have an abstract method, you can't instantiate a class. We have to say this class is abstract. We're not allowed to instantiate it. So there we go. There is our abstract class. And there's also my dog wanting to come in. Okay, so I think we're good here with our character class. This is abstract base class for our characters. Now let's make specific subtypes. That it will inherit everything that's in character. We're going to make new classes based on the character class. So let's make a class called Homer, and he's going to inherit character. So that's colon character, colon base class. That's the syntax. So we have made a class called Homer who inherits everything that's in character. Now, why are we getting this error message right here? It says Homer does not implement the inherited abstract member speak, right? So by subclassing character, we have to either implement the abstract functions that we inherit or make ourselves abstract. But Homer is a real character. We're not going to make him abstract. So let's give Homer a constructor, so CTOR, tab, tab. And let's put some sound bytes in the list of sounds. Sounds dot add, there we go, properties, I don't know, dot resources dot, what do we have, dot, oh, this has got to be a new sound player here, new sound player dot resources dot, what do we have? I've got Homer 1 2 3 4 5. All right, but how is that? That's a Homer by without the number is a bitmap, so we want Homer 1 2 3 4 5. Homer, there we go, Homer 1. And let's keep adding a bunch of these guys. 1 2 3 4 5. And you're like, where is sounds? I don't see sounds in the Homer class. That's up here in the character class. Homer gets that because he inherits from character. All right. And where does Homer's image get set? I don't know. Image equals Homer. No. Properties dot resources dot Homer. There we go. Okay, so now Homer has an image. And now let's go implement our speak function. So that's public void speak, and now I don't think we need the word override, because do we need the word override? We have to use the word override. Public override void. Try that. There we go. So even though the implementation, there's no implementation that we're overriding, I guess since we are providing a new implementation, we have to use the word override. And now let's play one of our sounds up here. So we'll say int r equals rand dot next, and then sounds dot count. Now we really don't need to we don't really need to be overriding the speak function, but it's just kind of an example of, we could imagine we didn't know how to do indexing or something like that. We could say if I equals 0. You know what? Okay, fine. Let's just play one of the sounds we have. Sounds sub I dot play. There we go. But like maybe the problem is we're going to get the same implementation here. For every character. What could we do differently? I don't know. All right, so there's our Homer. So Homer is inheriting character, and he's providing an implementation for the speak function, which is declared in the base class. I mean, what if we just did something like this? Dispensed with the list of sounds completely. All right, well, okay, so that works. I don't know. Okay, and then let's clone all this and turn him into Flanders. This will take all of, this is real easy now. This is just cut and paste. And I'll fix the missing semicolon there. Let's make a new class called Flanders. And he'll be a character also. We have to change the name of his constructor. And how many Flanders sound effects do we have? 1 2 3 4. 1 2 and let's change this image to Flanders. There we go. Okay. Now you can see, even though we're overriding the speak function, it really doesn't do anything different than Homer. So we probably could have just put this in the base class. We didn't need to really override it. And then also notice that we're not calling our base class constructor explicitly. Even if we don't explicitly call a base class constructor, we don't say :base like that. This gets snuck in here for us by the compiler. The compiler will insert that for us. All right, and then let's clone this guy and turn this into Ralph. Why are we getting expected? Oh, there we go. All right. Let's turn this into Ralph. So there's our. I'm trying to figure out where am I. So that's Flanders. Excuse me. And here's Ralph. And you know, maybe Ralph doesn't use his. Well, how many Ralph sound effects do we have? I don't know. Maybe we don't add anything to Ralph's list of sounds. And in here, in his speak function, maybe we just play one sound effect. New sound player, properties, dot resources, dot Ralph. How many Ralph sound effects do I have? I just have one. There you go. So Ralph is providing a speak function, but it's doing something just a little bit different from the other characters. So they all have a speak function, but it does something a little bit different. There we go. Okay, but they're all characters, and they all implement the public methods in the character class. So they all provide an implementation of that function. All right, so now let's go actually use these guys here. Up in our class here, let's make a list of characters. New list of characters. And in our constructor, let's go populate that. Characters add new Homer. Characters that add new Ralph. Characters that add new Flanders. So make 3 characters and put them all on that list. And why are we getting grief here? Ralph could not be found. So why can't we find Ralph? Let's go figure that out. Did I put Ralph inside of one of the other classes? I think I did. Did that fix the problem? And probably did the same thing with Flanders. Ugh. Excuse me. Let's go take Flanders here and take him. Somehow I put him inside the other class. So he's an inner class. We don't want that. Okay, so now there we go. We have Flanders and Ralph. All right, now let's go. Take a look at that again. So let's go back to our. So the point is we have a list of characters here. A character is our base class, and we've added a Homer, a Ralph, and a Flanders. And those are not characters. They are, I mean, they are, in terms of an is-a relationship. A Homer is a character, a Ralph is a character, a Flanders is a character, but they're specific subtypes of characters. And there's polymorphism right there. We can treat all of these 3 different things as one type of thing. All right, and then we need an index. Int index equals 0. And let's say, so now we know which character we're at. Picture box. So now let's put the character for the first character in the box. Picture box 1.image equals characters subindex dot image. All right, there we go. And now let's go implement our buttons. So if we run this, we should see Homer in the box. There's Homer. Okay, cool. Now let's go implement our next button in previous buttons. Previous. We'll say we'll say our index is minus. Subtract 1 from index. If index goes negative, we need to make it wrap around and go positive again. So if index is less than 0, index equals characters dot count minus 1. There we go. And then let's also refresh the image in the picture box. And then let's go to our next button. And this will be the same thing, just kind of mirrored. Whoops, went in there twice. If index is greater than or equal to the number of things in the list, then set index to 0. And then let's do our speak function. So that's, now we're going to go into our list, add our index, and tell that character to play. Speak. There we go. Call it speak function. And we don't know whether this is a Homer, a Ralph, or a Flanders, and we don't care because the implementation that gets called is determined at runtime. That's called dynamic binding. The speak function that gets called is determined by whatever that thing really is, and not what it's declared to be as at compile time. So at compile time, we said that this list had a character in it, but we don't get the character version of speak, and we can't because it's abstract. We get the version of the speak function which is bound to the specific subtype that object is. That's what dynamic binding is. You get the implementation that you think that you're going to get. You get the right one. You don't get the one that's based on the type of the collection that they all got put in. So let's run it and see if it works. Let's just see if we can cycle through our. So I should be able to. No? Why not? Oh, maybe I forgot to set Ralph's picture. You probably saw that coming a mile away. Ralph. Yeah, Ralph has Flanders' image. Ralph. There we go. All right, so there we go. I can cycle through my characters. Oh, the next button does not seem to be working. Why not? Let's go look at it. If the index is, oh, because I forgot to add 1 to the index. Index plus plus. If index is greater than the number or equal to the number of things in the list, set index back to 0. Okay, there's my mistake. So now I can cycle through my characters and.
Me fail English? That's impossible.
There you go. So we got Ralph's implementation of the speak function.
Roger, Dodger. Roger, Dodger. It's a miracle.
There we go. And we get, and so we're getting the speak function that we think we're going to get. It's the one that's bound to the character, the specific subtype of character, the Homer, the Ralph, the Flanders. It's not bound to the collection type.
That does it. I'm getting a computer.
There you go. Okay, so there's the first implementation of this. Now I think what we'll do is redo this using an interface, and this raises the question, when would you use an interface and when would you use subclassing? Well, it depends on the objects. If they have a lot of logic in common, if they have a lot of code in common, use subclassing. If all they have is in common is a list of public functions, then use interfaces. So that's kind of polymorphism works through interfaces and it works through inheritance. So why would you choose one over the other? If you have code in common, use subclassing and inheritance. If you don't have any code in common, then use interfaces. That would be my thoughts on that. So there we go. Well, there's polymorphism using The Simpsons.